Hello everyone. Today we discuss the topic classical IPC problems, synchronization and coordination in modern operating system. The concurrency challenge. By inter-process communication, IPC requires robust management. In the concurrency in OS, there are three threads: thread 1, thread 2, and thread 3. The producer-consumer problem. The producer-consumer problems are the bounded buffer problems involve two processes sharing a fixed size buffer. Producer generates data and places it into the buffer. Consumer removes data from the buffer for processing. Constraints. Buffer must not overflow or underflow. Readers-writers problem. Reading versus writing. Models access to a shared database. Multiple readers can access concurrently, but writers require exclusive access. Key strategies. First variation, no reader kept waiting unless a writer has permission. Second variation, once a writer is ready, no new readers may start. Dining philosophers, deadlock and starvation. Five philosophers sit around a circular table with five chopsticks. To eat, a philosopher needs two chopsticks. Deadlock. Everyone picks up their left chopstick. Starvation. A philosopher never gets both chopsticks. Sleeping barber. A classic synchronization problem involving a barber, a shop, and waiting chairs. Barber sleeps if no customer wait if barber is busy, customer leave if all chairs are full. Comparison summary. Classical problem, shared resources, primary risk, common tools. And producer consumer, the shared resources are fixed buffer. In primary risk, overflow or underflow. Common tools, semaphores, reader writers, database and file are shared resources. Inconsistency, primary risk, read write locks, common tools. Planning philosopher, resources tools, shared resources, deadlock, primary risk, monitor, mutex. Sleeping barber, service queue, primary risk, lost pickups, common tools, conditions. Synchronization hazards, race condition, outcome depends on specific sequence or timing of processes. Deadlock, two or more processes are stuck waiting for each other indefinitely. Starvation, a process is perpetually denied necessary sources to finish its work. Mechanism semaphores. Definition, an integer variable used for signing between processes. Wait decrements the value if negative, the process blocks. Signal increments the value, unblocks a waiting process. Binary versus counting. Binary acts as a mutex 0 or 1. Counting allows multiple access. S is initial value. If the formula used P of S means P of initial value. So S initial value is equal to initial value minus 1. Synchronization overhead, relative context switching, and latency overhead. Lower is faster. The semaphores, mutex, spin lock, lockless, atomic. There are force overhead that synchronization is used in lower and faster latency overhead. Beyond theory, database currency ensuring transaction integrity using reader-writer logs, socket buffer, network packets used, producer-consumer patterns for transmission, print spoolers managing shared printer access using queuing and signaling, kernel scheduling, dispatching threads across CPU cores using semaphores. Questions. Classical IPC problem in operating system. Thank you for your attention.